Good morning, students. Myself, Kaushik Chakraborty. In my previous video lecture, we discussed about the working principle of serial in, serial out shift register, serial in, parallel out shift register. Today's our topic is parallel in, serial out shift register. So, at first, we want to know what is parallel in, serial out shift register. In this register, we enter the data in parallel fashion, but we get the output in serial fashion. That means when we enter the data in parallel fashion, this time clock pulse is not necessary. But the when we get the output in serial fashion, this time clock pulse is necessary. This is the whole circuit diagram of parallel serial out shift register. Here we use the 4 D flip-flop. This D flip-flop is connected each other. This Xi is called input. This is Y0 is called output. Here we use the 4 negative clock pulse. These 4 negative clock pulse is connected each other. This terminal is called clear. This above terminal is called preset. Here we use the 4 2 input NAND gate. This 2 input NAND gate is connected each preset terminal of D flip-flop. This terminal, this terminal, this terminal and this terminal is connected each other. The value is always 1 and this 4 terminal is open. So suppose we take the 4-bit input value like 1 1 0 1. So this first NAND gate output is 1 1 0, but here we use a buffer. As a result, the entire value of this flip-flop is 1. Similarly, 1 this NAND gate output is 1 1 0, but the entire value is 1. This NAND gate output is 1 0, means output is 1, but the entire value is 0. This NAND gate, the output value is 0, but the entire value of this flip-flop is 1. So this is the truth table. When the clock pulse is 0, this time QD value is 1, QC value is 1, QB value is 0, QA value is 1. So output is 1. When we apply the first clock, this time QD value is go to the QC value, means QD value 1 is go to the QC value, QC value is go to the QB value, QB value is go to the QA value. That's why when the clock is 1, QD value is 0, QC value is 1, QB value is 1, QA value is 0. This time output is 0. Similarly, when the clock is 2, this time QD is 0, QC is also 0, QB is 1, QA is 1. Means this time output is 1. Similarly, Q3 and Q4. Next is timing diagram. This is the total timing diagram. This is clock pulse. This is one negative clock pulse. This is another negative clock pulse. At first, the QD value is 1 0 0 0 0, means when the clock 0, this time value is 1, otherwise all the value is 0. So initially the clock is 0, this time QD value is 1, otherwise all time this is 0, all time this is 0. Next, QC. Q clock value is 0, this time QC value is 1. Clock value is 1, this time QC value is 1. Clock value 2, 3, 4, this time QC value all are 0. So when the initially clock value is 0, this time QC is 1. Initially clock value 1, this time QC is also 1. When the clock value 2, 3, 4, this time QC value is 0, 0, 0. Similarly, QB are QA and Y0 are drawn here. So next class we discuss about the counter like ring counter and Johnson counter. Thank you.